Hello dear students, in this video I will teach you what are homogeneous equations. We say that a function f of x comma y is homogeneous of degree n if it can be expressed in the form x to the power n phi of y by x. So a function f of x comma y is said to be homogeneous of degree n if the function f of x comma y can be expressed in the form x to the power n phi of y by x. Now, if m and n, capital N, are homogeneous functions of x and y of the same degree n, small n, then the equation m dx plus n dy is equal to 0 is said to be a homogeneous equation of degree n. So, for a given differential equation m dx plus n dy is equal to 0 if m and n, capital M and capital N, are both homogeneous functions of x and y of same degree n, then the given differential equation is said to be a homogeneous equation of degree n. So, here we get two concepts. One is homogeneous function. Homogeneous function is nothing but when f of x comma y can be expressed in the form x to the power n phi of y by x. And homogeneous equations means equations, differential equations where m and n are both homogeneous functions of x and y of same degree. Now, in this case, we have a procedure for solving the equation. So let's see the procedure how to solve this equation, homogeneous equations. Here in this case, instead of m and capital N, we may write m is equal to x to the power n phi of y by x and capital N is equal to x to the power n psi of y by x. And we will substitute y is equal to vx so that v may be considered a new dependent variable. Now m dx plus n dy is equal to 0 will become a different differential equation because we have substituted m is equal to x to the power n phi of y by x and capital N is equal to x to the power n psi of y by x. Further, we have substituted y is equal to vx. So, m dx plus n dy becomes x to the power n phi of b dx because m is equal to x to the power n phi of y by x means b. So, m is equal to x to the power n phi of b, dx remains as it is, plus n is equal to x to the power n psi of y by x becomes psi of b because y is equal to vx means v is equal to y by x. So, n is equal to x to the power n psi of b plus multiplied by dy becomes x dv plus b dx. How? Since y is equal to vx, dy by dx, which is differentiating y with respect to x, will give us b plus x dv dx because b multiplied by d dx of x will give us b multiplied by 1 is equal to v plus x multiplied by differentiating v with respect to x will give us dv dx and multiplying dv dx with x will give us x dv dx. So, we will get dy by dx is equal to b plus x dv by dx or dy is equal to v dx plus x dv. We have cancelled the term dx from the denominator of both sides. So, our given equation becomes x to the power n phi of b dx plus x to the power n psi of b in the curly brace x dv plus b dx. Or in the next line, since x to the power n is multiplied with the entire equation, we have taken this common. So, x to the power n, inside the bracket we have written in the curly braces phi of b plus b psi of b dx plus x psi of b dv is equal to 0 or dv by capital F of b plus dx by capital F of x is equal to 0 because x to the power n cannot be 0. If x to the power n was 0, the entire homogeneous function will become 0. So, x to the power n is not equal to 0. So, we can say this entire part is equal to 0. Phi of b plus b psi of b dx plus x psi of b dv is equal to 0. Or we can rearrange the terms as dv by f of b plus dx by x is equal to 0. Here capital F of B is equal to V psi of V plus phi of B whole divided by psi of B. Or we can say F of B is equal to V psi of V divided by psi of B will give us B plus phi of B divided by psi of B. Thus the variables are separated because we had two variables, one is V, another is X. Here two variables are separated and now we can integrate and find the solution. So integration dvy capital F of P is equal to integration dx by x, or integration dvy capital F of P is equal to log C minus log x. Here C is our arbitrary integral constant and for better solution we have put log C instead of C. Or integration dvy capital F of B is equal to log of C by x, because log C minus log x will give us log of C by x. Now this is our solution. Now the primitive will be given by substituting y by x for v after the entire integration is performed. So whenever we are solving any homogeneous equation, we will substitute v is equal to y by x at last. After the entire integration is performed, we will substitute v is equal to y by x and we will get our required solution. So that is the form of homogeneous equations. Homogeneous function is f of x comma y is equal to x to the power n phi of y by x, and homogeneous equation means m and n both are homogeneous functions of x and y of same degree, and whenever we see a homogeneous equation we solve it by substituting y is equal to vx, and by substituting y is equal to vx we will get dy by dx is equal to b plus x dv dx, or dy is equal to v dx plus x dv. And after solving the entire thing, we will get at last integration dv by f of b is equal to log of c by x. And after entire integration is performed, we will put b is equal to y by x and we will get the required solution. So this was all about homogeneous equations. Thank you.